Lesson 10.1, Graphing Quadratic Functions. We were just working on factoring, and now we're going to introduce quadratic functions. Explain a little bit later how those two match up. Why do we care? Well, motion is a quadratic function. Motion on Earth, I should say. The classic example is just taking a ball and throwing it in the air. Goes up, gets to a top that we call a vertex, comes back down. That is a quadratic function, and it would be something along the lines of negative 16t squared plus 32t plus 12, something like that. The key point being a quadratic function has a second order polynomial, is a second order polynomial. Could be a trinomial, could be a binomial, but it's a second order, and that's why we study it. Pops up a lot in physics and in all sorts of other problems. So let's graph. How do we graph? 2x squared plus 2x plus 1. If you recall, we'll make a t-chart. Plug those in. Quick, put our coordinate plane in there. Plot our points. And I'm not going to plot 13. It's off the chart. Looks like it does something like this. And that's a classic shape of a parabola. Let's try it again. This is y equals 2x squared plus 2x plus 1. Fill in our points. Negative 2's down to 8. Negative 1 is at negative 4. 0 is at negative 2. 1 is also at negative 2. 2 is at negative 4. So again, looks something like that. And that's y equals negative x squared plus x minus 2. So notice some features. Feature number 1, we always have a vertex, which I'll just label as V. Notice that they match up side to side. The points match up. We call this symmetry. And we call that where we could fold the parabola over so it would land on top of itself, the axis of symmetry. So these are some of the key aspects of a parabola to help us graph them in the future. Notice also that this is down. The parabola opens down, and it has a maximum. And the maximum is the vertex. So that's this point here. Notice this one is up, and it has a minimum. The minimum is where the vertex is right there. We know it has minimum because this is positive. We know this has a maximum because this is negative. So the leading coefficient sign, positive or negative, tells us whether it'll open up or open down, whether it'll be a maximum or minimum. This may sound confusing once you've graphed a few. It really isn't that challenging. So let's find the axis of symmetry, then the vertex, and one other point. Make our lives a little bit easier. Turns out there's a formula. The axis of symmetry is x equals negative b over 2a, where the function is written as ax squared plus bx plus c. So this is my a value. That's my b value. And even though I don't care right now, that's my c value. So the axis of symmetry is negative negative 6 over 2 times negative 3 is at negative 1. So we go to graph, drawing our axis of symmetry at -1 here. We notice that it's got a negative out front, so it's going to open down or something like that. We'll figure it out. We take this -1, we plug it back in. Y equals -3 times -1 squared minus 6 times -1 plus 4 equals -3 plus 6 plus 4, 7. So 1, 2, 3, 4, 5, 6, 7. It's going to be up here somewhere. And it's going to come down. So we need one more point. Well, in this case, a nice easy point to find is the y-axis. So plug in 0, because that's when x equals 0. I'm running out of space here, so when x equals 0, y simply equals 4. You can see that these are going to cancel. You just get 4. So to get from the vertex, we went over 1, down 3. So we can do that on the other side. Over 1, up 3. The reason we can do that is it's a line of symmetry. What happens on one side happens on the other. And then we graph. And that's it. Takes a lot of practice. Follow the steps. Not too bad. Takes a little bit of time too. Flipping over. Now we're actually going to solve an equation by graphing. We would never do this, but it helps to see what's going on so that you can look at a problem and say, oh, I could factor that, I could graph it. Those two should match up and how. So, quadratic function, y equals x squared minus x minus 12. That's a function. Quadratic equation, replace the y with 0. Same thing. That's it. How do we solve this previously? We factored. And we might factor to make our graphing go a little bit easier, but in this case we're trying to turn it around. Trying to graph it and say what are the roots? And the roots are just the solution to this problem. More on that as we get along. So let's solve it by graphing. And again, I would never graph to solve a quadratic equation. I would factor it. I would use other stuff that we'll be coming up with shortly. But you'll actually be able to put it all together and see what's going on. So y equals x squared plus 6x minus 7. X equals negative b over 2a, which is negative 6 over 2 times 1, which is negative 3. Plug it back in, and we get y equals negative 3 squared plus 6 times negative 3 minus 7. 9, negative 9 minus 7, negative 16. Tough graph. Going to go by 2s. So, axis symmetry is at negative 3. Remember, I went by 2s. And down here at 16. Put in 0, I get negative 7. 2, 4, 6, 7. If it's symmetrical, there's 1, 2, 3 tick marks that way, 1, 2, 3 tick marks this way. So I should get about x equals 1, pardon me, 2. And let's fix that because I think it's actually going to hit at 1. So it'd be in between these two. 2, 4. So x equals about 1. X equals about negative 7. That would be my guess. So, 2 roots. And that's just what we call the solutions of quadratic equation. Let's graph this and let's factor this and see how we did. X plus 7, x minus 1, x equals negative 7, x equals 1. Hey, look at that. Our graph matches up. Guess I got lucky. So there were two roots. How about this one? I'm going to rewrite it as x. I don't know why us evil math teachers even do that. I'm going to put it all on the one side. And x equals -4 over 2 equals -2. That's my line of symmetry. And before I go any further, let's make sure it all fits. -2 squared is 4. -8 plus 4. Y is going to equal 0 on that line of symmetry. So -2 and 0. Positive value out front, so we know it opens up. We know it's going to hit 4 over 2. So only hits once. One root. X equals -2. Only root we have. I will leave it to you to factor this and see if you can figure out if that makes sense or not. Strongly recommend you pause the tape and do that. So, two more. We'll do them real quick. X equals -1 over 2 times 1, also known as 1/2. Plug that back in, we get 1/4 minus 1/2 plus 4. Which is 3.75. And I went to a decimal just to make it easier to graph. So we go to graph it, and we say x symmetry here at 1/2, and 3.75 about here. This is a positive value out front, so it's going to go up. It's going to hit at 4. So it'll also hit right here. And it does not hit the x-axis, so there are no roots. We'll call that something different when we get further down the line, but for now, no roots. Last one. X equals -6 over 2 equals -3. Plug it back in, get 9. -18. 9 plus -18 is -9. Y equals -2. So, put it all together. Axis of symmetry out here. Y equals -2 down here. Put in 0, I get 7. Way up here. Something way up here, which we won't graph. And my point is, it may or may not necessarily hit an integer. So we know we have two roots. But we don't know exactly what they are. Because if you look at this, it does not actually factor. It hits, there's two roots, but it doesn't factor, so we're going to get some decimals. What they are, I'd have to do a much more accurate graph to figure it out, which is why I said earlier we probably would not use graphing. However, it does show me we have two roots, or one root, or no roots. So graphically, you can see where factoring and graphing for a quadratic match up. Still a very confusing subject, but this is a good introduction. Work on graphing, and you'll start to put it all together shortly.